So let's go to the compiler. So the embed OS. And then the compiler. And if we make a complete new program, so new program, and then this is for that board, and we take an empty program, and we call it an McLab12. This is the PVM. And I'll call it with my initials, and this is version number 10, that I make a difference that which version. It created here an empty project, and on that empty project I need to import the operating system. And it was on the earlier lab instructions how you import the operating system in here. So import libraries. If you take it from a URL, you click here. And then to find the right address here, I had a look. It is in the GitHub. And it's the embed OS. So GitHub ARM embed. That's the main page. No, that's the embed OS. Yeah. Now we are on the operating system page. And the code we can copy by clicking here. And back to the compiler. Put the address in there. It's a library. Goes to that project of mine. And update all sublibraries. And import. And then it takes some time to import the operating system there once more. And it is importing us now the latest version of the latest published release of the operating system. And while we are compiling or importing the operating system there, we go back to the lab instructions and actually back to the course page, and under the lab instruction McLab12, you should also have a text file code McLab12 MOSFET PVM operating system 6. Click that one, and then you can, there are two versions. Wait a second. No. There is one version. Yeah, this is the document first, like my explanation, what is connected where, and then the code. And you copy the whole thing. So that was here on the course page under the McLab12, the code McLab12 MOSFET PVM operating system 6. So now when the code is, the operating system code is over there, then the next step is to create here the main program, so, or the main file. So new file, and it is the main.cpp. And then past the code which we found from our course page. And what we changed in our code, it is not anymore, we are not connecting the, we have a MOSFET gate, but it's not in the D10. It is in A1. So this is A1. Okay, that's also would be A1 if it would be just driving one LED. So if you haven't got anything to connect on the MOSFET and you would like to try that how the pulse width modulation works, then you can connect the just one LED there and then resistor and have a look that you can drive it with the pulse width modulated output. So I have the A1 to the MOSFET gate. And that was just my documentation. So I need to change it in here in the code. So that this is A1. And I have a loudspeaker in there. It might create a sound. Compiling. So it's getting ready to the compiling here, and then at the same time we can already connect our microcontroller board onto the computer. So it's driving the version that of the code that we had there earlier. So it was the display. And now it's the, you load there the new code, and then it's going to, should be giving a sound from the loudspeaker. We will see. To the downloads. So now on the downloads, we have the code, and then that's the board. And we should be driving with the MOSFET here, this loudspeaker. We will see what happens. How do you like it? So that was the nice sound from the loudspeaker, and that was created with the pulse width modulation. So the pulse width modulation is not typically used for driving a loudspeaker, but I just wanted to demonstrate that now the circuit is capable of driving something. So more typical is to drive a DC motor. So it drives the motor with variable speed. So if you didn't manage to test it now, so build the circuit carefully. Make sure that you don't connect the 5 volts directly to the ground, but through our circuit like we did it in here. And then test the code. It should work when you just carefully have a look that you have it in the right pin. So we were using the pin A1. Thank you.